In this video, I am going to be talking about word problems and what's recommended by the multisensory math course. Miss Zecker talks about how the What Works Clearinghouse compiles all this research and then determines what's the most effective sort of strategies that educators have been found to use. And illustrating word problems or drawing the word problems is considered one of the best strategies for students to understand what's being asked in the word problem. And so the multisensory math course really emphasizes teaching students how to illustrate word problems, doing it efficiently and effectively, and sort of having that as one of their main strategies, but also not to read the entire problem and not to look for keywords, because there's often multi-steps. So they might look at one keyword and assume it's a subtraction when ultimately it's an addition. And if they read the whole thing, a lot of times they'll drop information that was at the beginning. So Ms. Zecker recommends taking it sentence by sentence and drawing and illustrating and amending your drawing or modifying your drawing depending if anything changes throughout the word problem. So I'm going to give you an example of a grade 3 problem that was on the New York State end of the year assessment, and read through it to you sentence by sentence and show you how I would have a student illustrate it. So the first sentence is, a librarian receives 2 boxes of books for the library. So what can we draw there? Well, we can draw 2 boxes, right? We can do a very abstract, we're not looking for realism here, we're just looking for something representational for the library. The first box has 136 books. Well, it doesn't make sense to draw out 136 dots or whatever, so I'm just going to write the numerals for 136, and I can even write this as box 1. The second box has 58 fewer books than the first. Okay, so it has less, it's fewer, so I'm going to do minus 58 in this box, in this second box. And they want to know what is the total number, right? So what is the total number of the books the librarian receives? So I need to figure out first what's in this box, and I'm going to do that by, hopefully they would be able to infer that in order to figure out what's in here and then be able to add them, I have to subtract 58 from 136. So there first has to be the subtraction piece, 136, subtract 58, and then there has to be the addition piece of 78. So this would be 78. So then I have to cross this out, modify my drawing, and then I have to add them together to get my total. So that would be a simple illustration. That's 3rd grade level. All right. So I'm going to go ahead on to one that's a 4th grade level problem here. All right, so this one is, where is this assessment from? This might be the Park assessment, which is based out of Massachusetts, usually Park, but I think Park's in various places. So this one says, Caleb mixed red water and blue water to make purple water. All right, so I'm not sure exactly how I could do that, except maybe I could draw glass, right? And I could say, okay, maybe there's a glass there. Or maybe I could say, okay, here's some water, and I'll put that it's red, and then R for red, and here is some blue, and I'll put B for blue, and maybe there's a glass, right? So they got mixed in to make purple. Okay, P for purple. All right, he poured 2/8 of a cup of red water into a jar. Okay, so I'm going to kind of draw something that looks a little bit like a jar, right? So I'm going to be like, okay, this is my jar, and I have to cut it into 8ths. So 1/8, 2/8, 3, 4, 5, 6, 7. Didn't quite make it tall enough. Modify it. And 8. Okay, so he said he did 2/8 of a cup of red water. Okay, so here's 1/8 of red, and here's 2/8 of red. And then it says, after he poured blue in, okay, so he's going to pour the blue in, there was a total of 5/8 up here. So I got 1/8, 2/8, then here was 3/8, 4/8, 5/8 came up here, right? So how much blue water did he put in here? Well, now I can see, okay, I had 3/8 of the blue. And if I had another color, maybe instead I would tell students, let's make it a different shape to represent a different color. That could be a different thing. Okay, this would be my blue water, this would be my blue water, and this would be my blue water. And that shows me that I end up with how much blue water did he pour in? He poured in 3/8 of the blue water, because that's the question. So again, just helping them think through how can we represent this, not necessarily asking them to do the operation, but actually instead to do an illustration. One more here. A teacher plans to use ropes to make stations in the gym. Okay, so there's ropes. Each rope is a different length and color. Alright, so the teacher plans to make ropes. I don't know if I can really draw that, except I'll draw a couple ropes. Each one's a different length and color. Okay, so I'm going to anticipate that each one's going to be different color, and I might do a first letter of that color. And it says here the white rope, okay, so I'm going to put a W for white, is 45 feet long. The blue rope is 30 feet long, and the yellow rope, Y for yellow, is 10 feet long. And, obviously if students want to show the differences a little bit more, they could modify it to make this one different, but as long as they're just putting the number to indicate how long it is. Write an equation or equations to find the total length in feet of the white, blue, and yellow ropes. Use the letter T in your equation to show the total length of all the ropes. So in that case, then I would just do, of course, 45 plus 30 plus 10 equals T. So anyways, this illustration model, it's what I tend to use with my students anyways, and I think it's very helpful for them to just focus on saying, how can we approach this, how can we make sense of this, and how can we remember all the most important details through writing them down as we work through problems. And this is what she also recommends, so I think it's very effective.